Class 1 and Class 2 light fixtures differ significantly in their design and safety features. Class 1 light fixtures are characterized by having conductive parts enclosed within a metal frame or casing that is grounded. A ground connection is essential for safe operation. The exterior casing is typically metal, providing a conductive path to ground. Class 2 light fixtures, conversely, feature double insulation. This means the fixture has two layers of insulation separating the live parts from the user. Consequently, Class 2 fixtures do not require a ground connection. The exterior of a Class 2 fixture is made of non-conductive materials like plastic or porcelain. Key differences lie in several areas. Firstly, grounding. Class 1 fixtures require grounding, while Class 2 fixtures do not. Secondly, conductive parts. Class 1 fixtures have exposed conductive parts that are grounded, whereas Class 2 fixtures do not. Thirdly, materials used. Class 1 fixtures typically use metal casings, while Class 2 fixtures utilize non-conductive materials. In terms of applications, Class 1 fixtures are suitable for areas where grounding is readily available. This includes indoor residential, commercial, and industrial settings. Class 2 fixtures are best suited for environments where grounding is not practical or where there is a heightened risk of electric shock. Examples include bathrooms, kitchens, and outdoor locations. Safety benefits are a primary consideration in their designs. In Class 1 fixtures, grounding ensures that any electrical fault will be safely discharged to the ground, thereby preventing electric shock. In Class 2 fixtures, the double insulation provides an additional layer of protection against electric shock even in the event that one layer of insulation fails. Therefore, the choice between Class 1 and Class 2 fixtures depends on the specific electrical environment and the level of safety required. Class 1 provides safety via a grounded metal chassis. Class 2 offers the same safety, but via double insulation and a non-conductive enclosure. Each method ensures safety from electrical shock. When considering the application of these two classes of light fixtures, it is important to consider the grounding availability of the location where it is to be installed. If a reliable ground exists, then a Class 1 fixture can be installed with confidence. If there is no reliable ground, then the double insulation of the Class 2 fixture provides a safe alternative. It is also important to consider the risk of electric shock at the location. Class 2 fixtures are often selected for locations where the risk of electric shock is higher, such as bathrooms or outdoor locations. This is because the double insulation provides an extra layer of protection. When dealing with electrical systems, it is always crucial to adhere to local electrical codes and regulations. This is important for ensuring not only personal safety but also to ensure the longevity and proper operation of the equipment. These codes provide detailed guidance on the proper selection, installation, and maintenance of electrical equipment. This includes light fixtures. These regulations are put in place to minimize risks and promote best practices within electrical systems. For example, the National Electrical Code, or NEC, contains specific articles and tables that outline the requirements for grounding and bonding electrical systems. These requirements are designed to minimize the risk of electric shock and fire. Proper grounding and bonding create a low impedance path for fault current, allowing the overcurrent protective device, such as a circuit breaker, to quickly trip and energize the circuit. Article 250.4 of the NEC covers general requirements for grounding and bonding. This section emphasizes the importance of creating an effective ground fault current path. This path must be permanent and continuous, and it must have sufficient capacity to safely conduct any fault current likely to be imposed on it. Table 250.122 in the NEC provides guidance on the minimum size of equipment grounding conductors for various circuit sizes. The size of the grounding conductor is determined by the size of the overcurrent protective device protecting the circuit. The NEC also addresses specific requirements for different types of grounding systems. These include grounded systems, such as those found in most residential and commercial buildings, and ungrounded systems, which are sometimes used in industrial applications. Each type or system has its own unique requirements for grounding and bonding. Article 410 of the NEC covers the requirements for luminaires, lamp holders, and lamps. This article addresses the installation of lighting fixtures, including requirements for support, wiring, and grounding. Section 410.44 of the NEC specifically addresses the grounding of luminaires. This section requires that all metal parts of a luminaire that are likely to become energized be grounded. This includes the metal housing, the metal mounting bracket, and any other exposed metal parts. There are exceptions to this requirement for certain types of luminaires, such as those that are double insulated. These fixtures are designed to provide a high level of protection against electric shock without the need for grounding. Double insulated fixtures are marked with a symbol consisting of a square within a square. This symbol indicates that the fixture has been tested and certified to meet the requirements for double insulation. When installing lighting fixtures, it is important to carefully follow the manufacturer's instructions. These instructions will provide detailed guidance on the proper installation of the fixture, including any specific requirements for grounding and bonding. It is also important to use the correct wiring methods and materials. The NEC specifies the types of wiring methods that are permitted for use in different locations. It is important to select a wiring method that is suitable for the environment in which it will be installed. For example, in wet locations, such as bathrooms or outdoor areas, it is important to use a wiring method that is listed for wet locations. This will help to prevent moisture from entering the wiring and causing a short circuit. In addition to grounding and bonding, another important safety consideration is overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. These devices will automatically trip or blow when the current in a circuit exceeds a safe level. This helps to prevent damage to the wiring and equipment, and it also helps to prevent fires. The NEC specifies the types and sizes of overcurrent protection devices that are permitted for use in different applications. It is important to select an overcurrent protection device that is properly sized for the circuit it is protecting. For example, a 15 amp circuit should be protected by a 15 amp circuit breaker or fuse. Using an overcurrent protection device that is too large could allow the circuit to become overloaded, which could lead to overheating and a fire. Regular inspections and maintenance are essential for ensuring the continued safe operation of electrical systems. Electrical systems should be inspected periodically by a qualified electrician. During an inspection, the electrician will check for any signs of damage or wear, and they will also test the operation of the various components of the system. Any problems that are identified during an inspection should be promptly repaired. Regular maintenance can also help to prevent problems from developing in the first place. This includes tasks such as tightening connections, cleaning components, and lubricating moving parts. By following these safety guidelines, it is possible to minimize the risk of electrical shock and fire. Electrical safety is everyone's responsibility, and it is important to take the necessary precautions to protect yourself and others. Double insulation is a crucial safety feature in Class 2 electrical appliances and equipment, and it involves implementing two independent layers of insulation between the live parts and the accessible surfaces of the device. This design ensures that even if one layer of insulation fails, the user is still protected from electric shock. The first layer of insulation, known as basic insulation, is the primary insulation that surrounds the live conductors and components. This layer is designed to prevent direct contact with the live parts under normal operating conditions. The second layer of insulation, known as supplementary insulation, is an independent layer of insulation that is applied in addition to the basic insulation. This layer provides an extra level of protection in case the basic insulation fails. The supplementary insulation is typically made of a different material than the basic insulation, and it is designed to withstand higher voltages and temperatures. The two layers of insulation are carefully designed and tested to ensure that they provide adequate protection against electric shock. The insulation materials used in double insulated appliances must meet stringent requirements for electrical strength, thermal stability, and resistance to environmental factors. Double insulation is typically achieved by using non-conductive materials for the enclosure of the appliance, such as plastic or reinforced fiberglass. These materials provide a physical barrier between the live parts and the user, and they also help to prevent the spread of fire. The internal components of the appliance are also carefully insulated to prevent any exposed metal parts from becoming energized. Double insulated appliances are marked with a symbol consisting of a square within a square. This symbol indicates that the appliance has been tested and certified to meet the requirements for double insulation. The double insulation symbol is typically located on the appliance's nameplate, along with other important information such as the voltage and wattage ratings. Double insulation is a widely used safety feature in a variety of electrical appliances and equipment, including power tools, kitchen appliances, and lighting fixtures. It is particularly important in applications where the user may be in contact with water or other conductive materials, as this increases the risk of electric shock. Double insulated appliances do not require a connection to ground, as the double insulation provides sufficient protection against electric shock. This eliminates the need for a grounding wire in the power cord, which can simplify installation and reduce the risk of ground faults. However, it is important to note that double insulated appliances should still be used with caution, and they should be inspected regularly for any signs of damage. If the appliance is damaged or if the insulation is compromised, it should be repaired or replaced immediately. In addition to double insulation, other safety features that may be used in electrical appliances include fuses, circuit breakers, and ground fault circuit interrupters, known as GFCIs. These devices are designed to protect against overloads, short circuits, and ground faults, and they can help to prevent electrical shocks and fires. Fuses are overcurrent protection devices that contain a thin wire that melts and breaks the circuit when the current exceeds a safe level. Fuses are typically used in older electrical systems, and they are relatively inexpensive and easy to replace. Circuit breakers are also overcurrent protection devices, but they use a mechanical mechanism to trip and break the circuit when the current exceeds a safe level. Circuit breakers can be reset after they have tripped, which makes them more convenient than fuses. GFCIs are devices that detect ground faults, which occur when current leaks from the electrical circuit to ground. GFCIs quickly interrupt the circuit when a ground fault is detected, which can prevent electrical shocks. GFCIs are typically required in bathrooms, kitchens, and other wet locations where the risk of electric shock is higher. When working with electrical appliances and equipment, it is important to follow all safety precautions and to use the proper tools and equipment. Always disconnect the power before working on any electrical appliance, and never work on electrical equipment when you are wet or standing in water. If you are not comfortable working with electrical equipment, it is best to hire a qualified electrician to do the work for you. Electrical safety is a serious matter, and it is important to take the necessary precautions to protect yourself and others from electrical shocks and fires. When examining the use case environments for Class 1 and Class 2 light fixtures, it is important to consider that Class 1 fixtures are frequently employed in commercial and industrial settings. In these environments, a reliable grounding infrastructure is typically available. This availability of a grounding system aligns well with the design of Class 1 fixtures, where grounding is integral to their safety mechanism. The metal casing of these fixtures is connected to the ground, providing a direct path for any fault current to flow back to the source, tripping the circuit breaker and quickly de-energizing the circuit. This design is particularly beneficial in environments where electrical equipment may be subjected to more demanding conditions or higher levels of stress. On the other hand, Class 2 fixtures find extensive use in residential environments, especially in areas where moisture is present, such as bathrooms and kitchens. The double insulation design of Class 2 fixtures eliminates the need for grounding, making them a safer option in situations where grounding may not be readily available or reliable. The non-conductive exterior of these fixtures also reduces the risk of electric shock, as there are no exposed metal parts that could become energized. Furthermore, Class 2 fixtures are often used in portable appliances and equipment, as they do not require a grounding wire and a power cord. This makes them more convenient to use and reduces the risk of ground faults. In outdoor applications, Class 2 fixtures are frequently employed due to their inherent safety features. The absence of a ground connection eliminates the risk of ground loops and stray currents, which can be a concern in outdoor environments. Additionally, the non-conductive exterior of Class 2 fixtures provides protection against the elements, as it is not susceptible to corrosion or other forms of degradation. When selecting light fixtures for a specific application, it is essential to consider the environmental conditions and the availability of grounding. Class 1 fixtures are a suitable choice when grounding is readily available and the equipment may be subjected to demanding conditions. Class 2 fixtures are a safer option when grounding is not available or reliable, or when the equipment is used in wet or outdoor environments. Regardless of the type of fixture chosen, it is crucial to ensure that it is installed in accordance with all applicable electrical codes and regulations. This will help to ensure the safety of the installation and prevent any potential hazards. The International Electrotechnical Commission, or IEC, is a global organization that develops and publishes international standards for electrical, electronic, and related technologies. The IEC standards are widely recognized and used around the world, and they provide a framework for ensuring the safety, reliability, and interoperability of electrical equipment. IEC 60598 is a series of standards that covers the safety requirements for luminaires, which are complete lighting units consisting of one or more lamps, together with the parts designed to distribute the light, to position and protect the lamps, and to connect the lamps to the electrical circuit. IEC 60598-1 is the general requirements and tests standard for luminaires. This standard specifies the general safety requirements for all types of luminaires, including Class 1 and Class 2 fixtures. It covers a wide range of topics such as protection against electric shock, protection against fire, mechanical strength, and thermal endurance. IEC 60598-2 is a series of particular requirements standards for specific types of luminaires. For example, IEC 60598-2-1 covers the particular requirements for fixed general-purpose luminaires, while IEC 60598-2-3 covers the particular requirements for luminaires for road and street lighting. These particular requirements standards supplement the general requirements of IEC 60598-1 and provide more specific guidance for the design and testing of different types of luminaires. The IEC standards for luminaires classify luminaires into different protection classes based on their method of protection against electric shock. Class 0 luminaires are those in which protection against electric shock relies on basic insulation only. These luminaires do not have a means of connecting the conductive parts to a protective earth conductor, and they are generally not permitted in most countries due to their high risk of electric shock. Class 1 luminaires are those in which protection against electric shock relies on basic insulation and a connection to a protective earth conductor. The conductive parts of the luminaire are connected to the earth conductor, which provides a low impedance path for fault current to flow back to the source, tripping the circuit breaker and quickly de-energizing the circuit. This design provides a high level of protection against electric shock, as any fault current will be safely conducted to ground. Class 2 luminaires are those in which protection against electric shock relies on double insulation or reinforced insulation. These luminaires do not have a means of connecting the conductive parts to a protective earth conductor, but they are designed with 2 layers of insulation between the live parts and the accessible surfaces. This double insulation provides an extra level of protection against electric shock, even if one layer of insulation fails. Class 3 luminaires are those in which protection against electric shock relies on supply at safety extra low voltage, or SELV, and in which voltages higher than SELV are not generated. SELV is a voltage that is low enough to be considered safe to touch, typically no more than 50 volts alternating current or 120 volts direct current. Class 3 luminaires are typically used in applications where there is a high risk of electric shock, such as in swimming pools or other wet environments. The IEC standards for luminaires also specify the requirements for testing and marking of luminaires. Luminaires must be tested to ensure that they meet the safety requirements of the applicable standards, and they must be marked with the appropriate protection class and other relevant information. The marking must be durable and legible, and it must be located in a conspicuous place in the luminaire. In addition to the IEC standards, there are also other national and regional standards for luminaires. These standards may have different requirements than the IEC standards, and it is important to ensure that luminaires comply with all applicable standards in the country or region where they are being used. The Class 1 and Class 2 designations for light fixtures signify fundamental differences in their electrical safety designs. These differences dictate their suitability for various applications. Class 1 fixtures rely on a grounded metal enclosure to provide a safe path for fault current. This design necessitates a connection to a reliable grounding system, making them ideal for commercial and industrial settings where such grounding is readily available. Class 2 fixtures, on the other hand, employ double insulation to achieve electrical safety, eliminating the need for a ground connection. This characteristic makes them well suited for residential environments, particularly in locations where grounding may be unreliable or non-existent, such as bathrooms and kitchens.